Everything up to this point has been Mendelian genetics. The nice, easy, simple things that make sense. Today and this week, we're going to look at the parts of genetics that don't always make sense. Some people get very confused with some of this. So you just got to roll with me, roll through it, and hopefully it will make sense at the end. All right? Mendel had it easy. His was stroke of luck that he figured out dominant versus recessive. All right? Dominant always shows, recessive doesn't. All right? All right. We know if we have a dominant trait and a recessive trait, which one are we going to see? You're going to see the dominant. Only way to see the recessive is to do what? Have two recessive. That doesn't always work. Okay? That's Mendelian genetics. We're going to look now at non-Mendelian, meaning it doesn't follow that nice, simple, clear-cut pattern. In fact, today, we're going to do some crosses that have no recessives. Period. Okay? First thing we're going to look at is codominance. We've had the prefix co before on a quiz. It means together. Dominant, two dominant traits or two dominant alleles being put together. All right? On the notes, somewhere, star, bold, circle, whatever, no blending. Okay? Normal, when you see a a red and a white, you put them together, what do you normally get? A pink. That's blending. With codominance, they don't blend. So if you look down here at the bottom at the example, red and white. You put a red flower and a white flower together, does that look pink? No. Both of these traits or these alleles are dominant alleles. Red's dominant, white's dominant. And neither one of them want to give up that dominance. So instead of it one giving in to the other, you're going to see both. So we have a red and white spotted flower. All right. Both alleles are shown. You see this in animals. Anybody know what a Dalmatian is? A Dalmatian dog? They're black and white spotted. It's because of codominance. The black and the white trait or allele in their hair color, neither one wants to give up dominance, so you see both. If that dog's hair color was from normal genetics, Mendelian genetics, you would either see a black dog, a white dog, or what? You wouldn't see black and white spotted. You might, with another one, you might see gray, but you wouldn't see both of those traits together. You wouldn't see black and white. Okay, you see one or the other. But since it's codominant, you see both. We also have this in cattle as well. See this on a regular basis. So here's how a Punnett square would look for codominance. Notice you got a red flower on top, white flower on the side. What do we not see? What's missing? There's no recessives at all. Okay, because everything is dominant. These guys are neither. They're not red. They're not white. They're both. They're red and white. Red and white spotted. All right. Since we have all dominants, the R is dominant, the W is dominant, which one goes first? Why? You put them in alphabetical order.
Oh my God, that's actually what it said.
Put them in alphabetical order. So if this was a B and this was an S, it'll be BS.
I knew you were
All right. So we get 100%, 100% black and red and white spotted from this. Hey, innocence is good. All right, so some practice problems. Said it also happens in cattle. I deal with this on a regular basis. I have red cattle. All right. Hair color in cattle. Red. It can be white. Or it can be what we call roan. A roan color is a red and white spotted. All right, means you see both colors. It's asking you to cross a homozygous white. What would be my genotype for homozygous white? Big W. Big W. With a roan bull. What would be my genotype for this roan bull? Use the square, do the cross.
Does your cell organize it by alphabetical? How does it?
It just knows. It's built in. Because there's not actual letters in your DNA. Alright, what's going to be in my Punnett square? What would be my possible genotype outcomes? Genotype. 50% RW, 50%. Got W. What would be my possible phenotype outcomes? 50% white, 50% red and white, spotted. Okay. Making some sense? You got to get past that red and white makes pink, black and white makes gray. Doesn't always work that way in genetics. Try this one. That's something totally different. We're looking at dominance. So number 2. Why is there no Punnett square for this one on your sheet? Yeah, you can do it without a Punnett square. It says, what should the genotypes and phenotypes for parent cattle be if a farmer, that should say rancher, farmer only wants red-haired cattle? What's the only way I can get red? If I started with 2 whites, am I going to get red babies? If I started with a roan and a white, will I get red babies? No. If I start with 2 roans, will I get only red babies? Because I got this W in here. What's the only way I can get red babies? All red. 2 red parents gets me all red babies. This works. I see it. I've got red cattle. If I breed one of my cows to a black bull, I'm not getting a red baby ever out of that. It won't happen. If I breed it to a white bull, it will never get a red baby. All right? It has to be, you have to breed to the same color to get the same color. Okay? Because of codominance. Cats. Same thing. Similar in cats. Everybody know what a tabby cat is?
Yeah.
All right? You're going to cross a black cat with a tan cat to get a tabby cat. What's going to be my tabby cat genotype? What's going to be my tabby cat's genotype? BT. All right? So the question says, what percent of kittens would have tan fur if I cross a tabby with a black? Tabby with a black. Why is there no square with this one? Yeah, you don't need one. No, what we've learned up till now, you should be able to look and see. It wants to know how many will be tan. What do I have to have a genotype of to be tan? This parent can give a T. Can this parent? Will I get any tan? 0%. because each parent has to have some tan. Okay? You can do the cross, you can do the square, you can do all that work, you'll get the same answer. But if you look at certain things that we know is true, it makes it a lot simpler. All right? Does codominance make sense? Two alleles that do not want to give up their dominance, so they both happen. All right? The second one is incomplete dominance. Incomplete is the exact opposite. So we had two that didn't want to give up their dominance. Now we have two that neither one wants to take control. Okay? This star highlight circle, this is blending. This is your red and white make pink. Okay? This is how we normally think. Red and white make pink. Black and white make gray. All right? Yellow and blue make green. This is our normal blending. Okay. However, huh? I can't tell, you know, I mean, no facial expressions. All I see is the back of a hood. Right. So we have a blending. We have a third phenotype now. Before you turn the page to the second page of notes, look at the first Punnett square that was up there on your notes and compare it to this Punnett square right here on the board.
Looks like the same.
What do you notice?
It's the same thing.
They're the exact same. So how do I tell if it's going to be an incomplete dominant or a codominant? I'll get to that in a minute. All right, I'll show you. They have to give you some information in order for you to figure that out. Just by looking at this, you can't tell, because this is the exact same Punnett square for codominance if I did two of the opposites. Okay? But this time, instead of this meaning red and white spotted, now it means pink. All right? Because neither one of these two guys wants to take charge. They both want to just be there, so they blend together, and you see neither one of the dominants. Okay. All right, so we're gonna look at a yada bird. Yes, that's a real bird. A yada bird. We're talking about dominance now, so give me the genotype for my blue yada bird. Big, big. It's going to be crossed with a white yada bird. When that cross happens, we get a silver. Silver in genetic terms is a form of blue. All right. It's like gray is a form of black, pink is a form of red, silver is a form of blue. It says cross a blue with a white. Now, before you use that square, don't mess up that square. Do you need it? Can I just look at these two parents and tell what's going to happen? What's the only thing this parent can give? This parent can only give a big B. What's the only thing this parent can only give? So I'm going to get 100% silver. Do I need to do all that work? All right. If you don't need to do all the work, save yourself, save you some mistakes. Use the little shortcuts. All right. Second one, cross two silvers. What's going to be my genotype for a silver? So I'm going to cross two silvers. Okay. And the question says, what's the phenotype ratio of the offspring? Now, go back to regular genetics, Mendelian genetics. What's a word that describes this genotype right here? Heterozygous. When I cross two heterozygous, what's my genotype ratio?
1-3-1.
1-2-1. What's my phenotype, which y'all missed on the quiz, on the test? Phenotype ratio is? These three are going to be the same. 3-1. That's Mendelian genetics. It still applies here, okay? Not completely, but mostly. If I do the cross for this, I should get the same genotypic ratio. Do I get a 1-2-1 genotype ratio here? One of these, two of these, one of those. Genotype ratio is the same. We're still doing two heterozygous. But now, what's my phenotype ratio going to be? Will it still be 3-1? I've got one blue. Normal genetics, these two would be blue, but they're not here because we got two dominants. So these two are silver. That one is white. What's my phenotype ratio? 1-2-1. Okay. Two heterozygous. So this is regular Mendelian genetics. Non-Mendelian, we have the same ratio for both. All right. So if the question on the test that y'all missed would have been non-Mendelian, y'all chose that, you'd have been right. But it wasn't. Okay. Make sense?